Troubleshooting IPv4 access lists. Here's your flyby. I believe access lists should have been called matching lists because that really describes what they do. They match traffic going through your router and you get to decide what happens to it. Now, that decision is influenced only by what feature you're applying the access list to, right? Because you can use an access list for security, like this guy standing right here, traffic going into or out of your router, but you can also use it for NAT and dictate what traffic gets natted through the device. You could use it for quality of service to say what traffic gets prioritized and which one doesn't. You could use it for VPN to say this gets encrypted, this does not get encrypted, and the list goes on and on and on. There's very few big features on your devices that don't require an access list in some way to identify traffic. So obviously it's a huge importance to understand how these things work. First off, an access list is just a list. I mean, you could open Notepad and type the list up of statements that are read from top to bottom, and the router will stop at the first match. So for instance, if I have this little guy right here who matches permit 10.1.1 or 10.1.5.1, and further down the list you have deny 10.1.5.0/24, the whole subnet, is never going to reach that one because as soon as it gets the first match, it stops and processes the packet based on the instructions. There's always an invisible implicit deny at the bottom of the access list. And one of the things I always do, and this is just real world, I always add the deny IP any and I'm thinking extended access list right now, to the bottom, so I can actually not only see the implicit deny, but if it's invisible, you can't tell if anything matches it, right? So by typing the statement at the bottom of the list, you can actually see when there's packets matching and packets being denied in there. I set up just a simple topology to demonstrate access lists. Using GNS3, I actually shut the right wing down over here. I've just got my left wing router, router 1, .1 on both sides. You can see the subnet 10.1.1.0, 10.2.2.0. So let's pull up router 1. And as of right now, everything goes through. So I'm going to just bring up PC2. Just assign an IP address. Let's just ping 10.2.2.1. Make sure everything's working. Looks good. Ping 10.1.1.1. That's the other side of the router. And we'll ping 10.1.1.50, which is the broken PC on the other side. Oh, okay, good. It just took a second. So I'm glad we tested. We've got full connectivity going from PC2 to PC1, right? So let's do a basic standard access list to start off with. I'm going to go on router 1 and do a global config mode. You can do numbered access list by just typing in access list and what number you want, which dictates what kind it is. Or what I like to do is use the named access list by typing in IP access list. We'll say it's a standard one. We'll just call it test. it is case sensitive. So I'm going to say I want to deny the host. We'll say 10.2.2.0, or actually 10.2.2.50, right? Which is going to be this guy over here, and permit anyone else. That's a standard access list, not too much to it. So when I go into interface fast Ethernet 0/1, which, let's get that topology up here so we can see what's going on. Fast Ethernet 0/1, grab my pen, which is the interface connected to this guy right here, and apply it. Now, direction is hugely important because if we apply it outbound, that only affects traffic going to this guy, and that's not the purpose of this access list. We want to catch it on the inbound. Now, one of the rules you may remember from access lists is with standard access lists, you always want to apply it as close to the destination as possible because you'd have no granularity in what you're blocking. When I say deny 10.2.2.50, then I can't really say deny from what, so you want to go as close to the destination as you can and put that block up, because otherwise you might deny them from too much. Whereas extended access lists, you want to apply as close to the source as possible, because you can say what source and destination and port numbers are all denied, and it keeps the guy from crossing too many network devices needlessly just to find out he gets to the other end and is denied, right? So let's see, where was I? I was on router 1. I'm going to go into fast Ethernet 0/1 and apply it using IP access list, or IP access group 1, test inbound. Right? So I'm going to come over here to PC2, try the ping again, and sure enough, you can see this guy's receiving ICMP replies, which is great when you have an access list, which says communications administratively prohibited. Now, remember, you're only going to see those ICMP replies, and this goes for your troubleshooting, on the first devices. They don't go through multiple routers. So, for instance, if I had another router going between PC2 and PC1 and applied that same access list here, he would send the ICMP denial to this guy, but that's where it would stop. Essentially, this guy would see request timed out. Request timed out. He wouldn't actually see that something is blocking him from reaching the other side, right? Okay. So I can go into that access list. Let's do a show IP access list. And I can see the deny is definitely getting matches, so this guy's ping traffic is being stopped. Good. Basic access list. Let's go in and do a no IP access list test. We'll then go in and go extended on it. We'll do IP access list extended, and we'll call it a big test. Right? And in here I'm going to say, well, I want to deny the TCP traffic coming from the host 10.2250 to the destination of, let's just say, host 10.1150, the guy on the other side, equal to, and we can go in and do, let's just say, 80, right? We're going to stop web traffic. I can then permit IP from, let's just go the whole subnet, 10.220 wildcard mask 255 to the destination subnet 10.110.000.255. Enter. No port needed because IP is every protocol. So now we should be able to see some decent matches. And by the way, this does overrule that implicit deny, because essentially there's nothing coming from 10.220 that will ever be blocked because we've permitted everything, at least to the 10.1.1 subnet. Okay. So let's go to PC2. I'm going to go in and do a quick ping 10.1.150, which should not be blocked anymore. Right? Right. Just takes a sec to come up. So we've got the connection going through. If I do a show IP access list, I should see that forgot to apply it. Interface fast Ethernet 0/1. We'll do IP access group big test inbound. Now, the rule is you can only have one access list applied per interface, per direction, per protocol, protocol being TCP/IP. So when I do show run interface fast Ethernet 0/1, you can see this guy replaced the previous one that I had in there. I didn't need to type a no command. So now I'll hit the up arrow, try that ping again, and I should be seeing, matches coming in on that permit statement going to the other side. But when I do another ping, let me just refresh the command here. I can do a ping 10.1.150. What's the option? Let's go TCP. So we'll say -3 TCP mode. So it's going to emulate some TCP traffic using port 80. Bam. Communication administratively prohibited. Yeah, so we're actually seeing the access list go into action blocking the web traffic, whereas let's just try port 81 flies right around it and pings to the other side. A lot of you may not have known the virtual PCs in GNS3 can emulate essentially all kinds of different traffic going through, so I can actually see all these matches coming through. This is good. This is good. This is the core review of access lists. Now, applying it can be applied again in so many different ways. I showed you in ways of security because it's quick and easy to test. But for instance, if I was doing NAT, I could do IPNAT inside source list, and then I could say the list that's allowed to be natted is that big test. So you can apply access lists in all kinds of different ways to invoke different features on your Cisco devices. So where can access lists go wrong? Well, I have the most common issues right on the screen, which again, as I look at these, I'm like, well, of course. But these are always embedded in a much bigger scenario in the T-Shoot exam, so you've got to turn over a lot of rocks to find them. Number one place, come on, who's done this? Access lists applied the wrong direction. Me, I'll raise my hand, because when you first get used to access lists, especially extended ones which have source and destination, and then combine that with inbound, outbound on routers, it just, your mind blows up, right? So the best way to remember it is to be the router. You know, you've got arms coming out of you. Here's your little head and legs and everything else, right? Your left arm is fast Ethernet 0/0. So when you're thinking, okay, I'm going to apply this on the inbound direction, if I'm the router, I'm thinking, okay, I'm expecting the 10.1.1 network to come in from that direction, right? So I'm looking that direction, and that's going to be the sources that I'm filtering on. Again, be the router, set yourself in the middle, and that will really help you determine the direction. Second is forgotten implicit deny, and I mentioned that before. Always manually add it to the bottom, especially if you're not used to it being there, because there's a lot of times you'll be in a panic. There's a new SQL attack that comes in, and you're like, I need to just create a quick deny, 3306 or whatever the case is, and you apply it right there, not realizing that an access list that denies, and that's the only statement, denies everything because of the implicit deny. Not understanding the logic. Maybe you match something earlier in the access list. So one way that you can find that is to log the results. You can actually add the log keyword. Let me pull that up. I haven't seen that before. So if I'm creating an access list, we'll just say 1 permit any, right? And then I can go in there and type in log at the end, which you can set to be sent off to a syslog server or logged right there on the terminal, so you can see whenever anything matches that access list and find out if maybe I'm getting an unexpected result from there. Finally, port number being in the wrong place. Also one I would ask for a show of hands. How many of you have done this before? Typically, when you're getting used to access lists, you're using context-sensitive help. So you're like, okay, access list 101, permit, okay, I need, protocol TCP from any source, okay, right there, equal to, and you're going through, right? You just killed yourself right here. Most of the time, equal to port 80, because you're actually matching the source port, right? And you go, okay, equal to any, enter. So you're actually, if you do this, are matching something sending from the source port of TCP 80 rather than going to the destination port of TCP 80, which is going to be the web server that you're trying to find, and you hose yourself up, right? Or you don't get matches when you expect to. Expect to see stuff like that on the T-Shoot exam, because again, if you're not super familiar with access lists and you do a show command, you're like, that looks right, it's matching www, permitting that through, okay, move on to the next thing, but it's in the wrong place. So your show commands to verify this is show run, and I always put section access list, right? So it will show you. I'll just do access list right there. It'll show you not only the header, access list big test, but then all the subcommands underneath it. If you just use include access list, a lot of times you'll miss all of these more detailed points. Show IP access list. I know this sounds funny. You can get the same output by typing in show access-list as show IP access list. The only reason I always go for show IP, simply because I can type it faster. If you have to put that dash in there, it's an unnatural, you're like, oh, where's the dash? Whereas everything else is, natural typing. Show run section interface, right? That'll show you where things are applied. So I can see the access group commands and where they're applied underneath there. Or if you are, for instance, banned from typing show run, I've seen that happen before on a certification exam. You can type in show IP interface, and I'll just focus in on fast Ethernet 0/1 and determine right. Oh, where is it? Hang on. Right there. Inbound access list set is big test. So you can see that in the list without having to do a show run command. And that is how you troubleshoot IPv4 access lists. I hope this has been informative for you, and I'd like to thank you for viewing.